Good morning. Today we are continuing on with probability with CO74. I can calculate the probability of compound events. So yesterday we were doing just one event, the probability of drawing a red marble, probability of drawing a 2 out of our deck. That's one event. Now we're going to talk about a compound event, which is two. I need to switch screens. All right, so bear with me. I need to switch which screen I'm on. There we go. All right, so that compound event is two or more events occurring. So instead of just drawing one marble, we might draw two marbles out of the bag. Instead of picking one card, we might be picking three cards. Okay, so we have those compound events. Okay, if you want to, you can move into there so it makes it easier. I'm still in Google it. All right, so compound event is two or more events occurring. So to find the probability of a compound event, you find the probability of each event like we did yesterday. So you think of each event that you're doing and you write down the probability, that fraction for each event. Then, so that's step one. Then you multiply the probabilities together. So step one is to find each event's probability. Step two is to multiply them together. The probability of all the events happening is the product, so that's the multiplication, the product of each individual event. So the compound event, to find that probability, you have to find the individual fractions, the individual probabilities for each event, then we're going to multiply those fractions together. So what does that look like? Let's put that into practice. So a bag of 20 marbles contains 5 blue, 8 red, 7 white. What is the probability of? So we've got our bag with all those different colors in it. What's the probability of choosing a blue marble, replacing it, and then choosing a red marble? So what would my first step be? Emma?
5/20.
Why 5 over 20?
Because there's so many blue marbles there.
There are 5 blue marbles and there's 20 altogether. So that's my first event, choosing a blue marble. So the probability would be 5 out of 20. I put that blue marble back in the bag. This is important. You always need to check with this objective. Are we replacing what we chose, or are we keeping it out? Why is that so important? Why am I making note of this, Lila?
Because if you didn't, then it would change, because instead of having 20 marbles, you only have 19.
If we don't replace that marble that we pick out the first time, if it says do not replace, not replacing, that changes your total number of marbles in the bag. Now you only have 19 marbles in the bag. Okay, so we have to really pay attention. Are we replacing it? This time we are, so we know our next probability is still gonna have 20 marbles in the bag. This time we want to choose a red marble. So what is my numerator going to be here, Liam? 8. There are 8 red marbles. So that's my step 1. I find the probability of the blue marble, the probability of the red marble. What do I do next? What's my second step? Adeline? I multiply them. So remember, when we multiply fractions, how does that work? How do we multiply the fractions, James? Go straight across. So I'm going to do 5 times 8 equals 40. 20 times 20 equals 400. Now we're at the same place we were at yesterday. What do I do to find this probability? Adeline? I'm going to divide the top number by the bottom number to get my decimal. What is 40 divided by 400? Kylie? Say it louder. 0.1, and then remember we want to go to that hundredths place, so 0.10. Yep. Now I need to turn that into a percentage. What percent would that be? Liam? 10%. So my compound probability, that probability of the compound events, would be 10%. That is my final answer. So let's look at our next one. Choosing a red, what's the probability of choosing a red marble, not replacing it, then choosing a white marble? How many events do I have happening? Adeline? 2. So I have event 1 is the red marble, event 2 is that white marble. Can we have more than 2 events sometimes? Yeah. If we have 3 events or 4 events, what would we do when we multiply across? Adeline? You just keep multiplying. We have a 5 times an 8 times a 7. You do that. And the same thing with the denominator. You multiply across. Okay, so it doesn't have to be just 2 events. You might have some questions that have more than 2 events. You do the same steps. So our first event is choosing a red marble. What is that probability fraction? Kellen? There are 8 red marbles and there are 20 marbles in our bag. What is the probability of choosing a white marble? What is that fraction? Liam?
7 out of 20.
Liam thinks 7, because there are 7 white marbles. And then he's putting a 20 down below. Should it be out of 20? Emma?
No,
Why not?
because you're not replacing it.
Because we always have to check, are we replacing after every event? This time it said not replacing. So if we picked a marble out for our first event, how many marbles are going to be left in our bag, Liam? We picked a marble out here, out of the 20. So I've got 1 marble in my hand. How many are left in the bag? If I had 20, and I take 1 away, 19. What is my next step? I have 8/20ths and 7/19ths. James,
Multiply 28 times 19.
I'm gonna multiply going across, both the numerator and the denominator. So what fraction do I get when I multiply across? So everybody should have their calculator out. Everybody should be doing the math. What fraction should I get if I have 8/20ths times 7/19ths? Jack,
56, over 380.
7 times 8 is 56, 20 times 19 is 380. What do I have to do next, Bennett? Divide the top by the bottom. What is 56 divided by 380, Bennett?
14. So,
What is the decimal that you get?
0.14.
0.1 what?
0.147.
0.147. When you have multiple decimal places, remember, we always have to go to that thousands place so you can know how you round your hundredth place. So Bennett, if my 4 is followed by a 7, does it stay the same or round up? It rounds up. 5 or higher in that thousands place means we're going to round up. So what should my decimal be, Bennett? 0.15. Okay? So always, always, always double check your rounding. The most common mistake people make, we round wrong. So look at that thousands place. If it's a 4 or less, then our hundredth place stays the same. 5 or higher, you round it up. So like Bennett said, if it's 0.15, that makes it a 15%. Then you can circle that as your final answer. Adam. So in our directions, it does not say we have to say likely or not likely, so you don't have to. Okay, always read the directions and see what the directions want us to. Last objective, it wanted us to. This objective, it's not listed, so you do not have to. You sure can if you want. All right, well, let me scroll up. All right, let's look at our next one. Choosing a blue marble, replacing it, then choosing a white marble. So write what your first probability fraction is, write what your second probability fraction is, and then see if you can do step 2. Write your first probability fraction with the blue marble, write your second probability fraction with the white marble, and then do step 2. What did you get for the blue marble probability? What fraction? Kylie? There are 5 blue marbles over 20. What was the white marble probability? Bennett?
7 over 20.
There are 7 white marbles. We replaced that first marble, so we're still at 20 marbles in our bag. What do I do for my second step? Noah and Nikki? What operation am I going to do for my second step?
Multiply them.
Multiply them. So what do we get when we multiply 5/20ths by 7/20ths? Liam? 35 over 400. Now I need to turn that into a decimal. So what math do I do to turn it into a decimal, Emma? I'm going to divide that top number by the bottom number. What decimal did you get, Sarah?
0.09.
0.09. What percentage is 0.09? Check.
10%.
9%. All right, Bennett.
I got it.
Let's do math that you did. So you didn't get 0.8, you got 0.0875. So what did we say we have to do when we round to the 100th place? What do we have to look at?
The thousandth place.
What number, what digit is in that thousands place? What does the 7 tell us to do, Bennett?
Go up.
To round it up. Okay, so you got the right decimal, you rounded incorrectly. So always look at that thousands place. 5 or higher, make sure you round that 100th up. James?
Can you show like, I divided 35 by 400 and then I got 0.0787 and then I put 0.09 and then I put 9%. Can I do that?
Yeah.
Okay.
Circle your final answer. Okay, so always circle that percentage. If you want to write out that whole decimal to the thousands place, and then look at it on your paper, making sure, oh, I'm underlining the 100, following it, yeah, that's totally fine. That's part of showing your work. Some of that people can do in their head, mental math. Some of us want to write it out to make sure that we're looking at the right digits. Totally fine to write it. All I'm gonna look at on the test is your final answer, okay? All right, work on the next one. Choosing 2 blue marbles, not replacing either, then choosing a red marble. How many events is that? How many events are we doing, Lila? 3 events, because it's the first blue marble 1, blue marble 2, then the red marble. So we have 3 events we're doing. So write your probability fraction for each of those events. Make sure you are reading the problem completely. Are you writing your events, Aaron? So write your events, then do your step 2s. Remember, we multiply all the way across. Are you writing your probabilities, Kaden? Okay, then multiply straight across. And see what decimal you get. And I am just gonna do this as a reminder. See if you can figure out why I circled that part of our problem. What does that change? We're gonna still let our friends work it out. We're not gonna answer that question yet. Some of us know what it changes. Some of us are going, oh, why did she circle it? Did he replace it to that last one? So, why am I not seeing any work right now? Well, have you seen everything I'm writing on the board? What are you supposed to do? Yeah, everything I write on the board, you write in your binder. So erase that, especially this one, because that one's still on the board. Erase it and write it out, every step. So that way we know all of our steps when we go back to review it next week. No. No. Why is everybody getting a different percentage? Let me use your calculator. Maybe my answer is not, maybe that's the same as me. Yeah, people are watching. Oh my goodness, I only have a few people that found the correct answer. Let's walk ourselves through this to see what our answer should be. Okay, what is our first probability fraction? James?
520.
There are 5 blue marbles out of 20. What is our second probability fraction? I think this is where a lot of us messed up. Lila? So Lila's saying, okay, we didn't replace that marble, so there's 19 left. But if we chose a blue marble the first time, and we don't replace that blue marble, how many blue marbles are left in the bag, Lila? There are only 4 left in the bag, because we chose one. We didn't replace that blue, so there's only 4 marbles, blue marbles left in the bag. So all of my friends that put that 3%, this is probably where you went wrong. Now, what's our probability with a red marble? Adeline?
8/18.
Yep, because we didn't replace either blue marble, so now we're down to 18. Oh, pat yourself on the back if you caught that there were only 4 blue marbles left, because most of us got stumped by that one. Good job thinking that one through. But now the rest of us, next time we come to a problem that's similar to this, we're going to say, ho, I'm not going to get tricked by that. Okay, so always think, if you take a blue marble out, what does it all change? So what decimal, or what fraction did we get when we multiplied all of those together using the correct numbers? James? 160 over 6,840. What decimal does that get us? James?
0.023.
0.023. My 100th place is followed by a 3, so I know it's going to round to 0.02, which gives me a 2%. Do you see where we went wrong on that one? Okay. Which is more likely, choosing 4 red, not replacing any of them, or choosing one of each color and not replacing any of them? So you're gonna have to find the probability of the first scenario, then find the probability of the second scenario and see which one has a higher probability. So let's look at that. Choosing 4 red and not replacing them, not replacing any of them. So you choose a red, you don't replace it, what's your next probability? Choose a red, you don't replace it, what's the next probability? So you have 4 marbles that you are choosing. You want 4 red. So red 1, red 2, red 3, and red 4. So figure out what the probability is for each of those fractions. What would our first fraction be? Adeline? 8 over 20. What's the probability for the second red marble? I know Adeline knows. Who else knows? What's the probability for the second red marble? Kylie?
8 over 18. 20.
So you were right with it being a 19.
Oh, 7.
Yeah, because we chose a red marble and we don't replace it. So now there's only 7 reds left. Now we have 2 red marbles out of the bag. We're not putting them back in. What is our third probability, Maddie?
6 over 18.
6 red marbles left and there are 18 marbles altogether. No, we don't replace it. We've got 3 red marbles out of the bag. What is our fourth probability, Hudson?
5 over 17.
5 over 17. And we're going to do step 2 of multiplying those all together. What is 8 times 7 times 6 times 5 over 20 times 19 times 18 times 17? What big, huge fraction do I get? Sarah?
1,680 over
116,000 and 280. What decimal does that bring me down to? Sarah?
114. 0. Wait. 0.1.
What is the whole decimal you get, Sarah? When you have 1,680 divided by 116,280.
0.01444.
Okay, I'm gonna stop at that thousands place. So 0.014. Where do I want to round to, Sarah?
100.
That hundredths place is that second place, so that 1 is followed by a 4. So what do I round that to?
1.
It's not 0.1. Because you're dropping off that 10th place. It's 0.01. So we want to be careful with that we keep it like that so we can figure out that percentage. Because if we just put 0.1, we might accidentally turn that into a 10%. So our 100th place has a 1, so it is 1%. Okay, so that's our first scenario. There's a 1% chance that we could get 4 reds in a row without replacing them. So now we need to figure out our second scenario, choosing one of each color, not replacing any of them. So how many colors do we have? We have the red, blue. I like to start at the beginning. So we have a blue, a red, and a white. So there are 3 colors we need to pick, not replacing any of them. So what is probability number 1? What is the probability of choosing a blue marble? Emma?
5/20.
5/20. 5 blues out of 20 marbles. What is the probability for picking a red? Liam?
8/20.
So, be careful, Liam. We know there are 8 reds, but we're not replacing. If you ever see not replacing in your problem, circle it so you remember that our total number is gonna go down. So what is our total number, Liam? 8/19, because we didn't replace our blue, so it went down to 19. What is the probability then of choosing a white? Jack?
7/19.
There are 7 whites, and it goes down to 18. Then we have to multiply those across. What decimal do we get when we multiply all of those across? Not decimal, what fraction do we get? Hudson?
280/6,840.
280/6,840. What decimal do we get from that? Adeline?
0.04.
Which is what percentage, Adeline?
4%.
So our question is, which is more likely? Our first scenario or our second scenario? Kylie? The second. So I'm gonna write more likely next to that second scenario. Because that 4% is higher than the 1%, so it's more likely. Let's look at our last one. If you choose 2 marbles from the bag, replacing the first one, what is the least likely outcome? Which one do you think is going to be the least likely? So this is one that we're not going to do. We're going to think it through, and then we're going to do the math. But what do you think, off the top of your head, would be the least likely combination to get? Maddie, what do you think?
5 blue.
So we're choosing 2 marbles. So which colors would they be, Maddie?
Blue and white.
Go with your original thought, but instead of saying 5 blue, we're choosing 2 marbles, it would be 2
Blue.
blue. Why would that be the least likely, Maddie?
Because there's the least amount.
That's the least amount of colors that there are, right? The blue only has 5, so there's a smaller number of your desired outcome. So if we chose a blue and we replace it, there's still only 5 blue. There's 7 white, there's 8 red, there's more of them, there's more of a chance of picking that color. Does that make sense why it would be 2 blue? Because it's the smallest number, least likely to choose. That's why I said we don't actually have to do the math on it. We're just going to pick the one that's the smallest number. Questions on the first page at all? Okay, remember those things that we had to think about, especially circling if our problem says not replacing. Think about what that all changes if you're not replacing it. Sometimes it's just the total number. Sometimes it's also that top number if it's the same thing that we're not replacing. Let's look at today's assignment. This time, instead of doing marbles, we have a spinner with 4 equal sections. So we've got our spinner here. It's got 4 equal sections. One section is red, one section is green, one section is blue, and one section is yellow. Okay. gonna be the same idea. Instead of drawing the marble out of the bag, you're spinning the spinner. What's it gonna land on? So we also have a die numbered 1 to 6. So how many total possible outcomes are there for the spinner? Lila? For the spinner.
Oh, 4.
There are 4 total possible outcomes for the spinner. How many total possible outcomes for rolling the dice, Lila? 6. So if you're doing a probability with the spinner, your total possible is going to be 4. If you're doing a probability with the dice, your total probability, or total outcomes would be out of 6. So we don't have to worry about the not replacing on this one because you spin. It's not drawing something out of a bag where you can't replace it. So our first question is, what is the probability of spinning a red? So your first event is 1 spin. Spin 1, spinning a red. And then rolling a dice. So our second event is to roll 1 time. So we have 1 spin and 1 roll. We have 2 events. We need to write down our probability for each event. So what's the probability for spinning a red? Adeline?
1/4.
There is 1 red section out of 4. 1/4. What's the probability for rolling a 5, Emma?
1 out of 6.
1 number 5 on the dice out of 6 numbers. Then we're going to do the same thing that we did on our first page. What is the second step? Kylie?
Multiply.
Multiply across. So 1 times 1 is 1. 4 times 6 is 24. Then what do I have to do? Emma?
Divide.
Divide the top number by that bottom number. What is 1 divided by 24? Bennett?
24.
Nope. 1 divided by 24. You did it the wrong way. You did 24 divided by 1. Our 1 is on top. You always put the top number in first. What is 1 divided by 24? Charlie? 0.041. We look at that hundredths place, it's followed by a 1, so we know it's 0.04. What percentage is that, Charlie? Very good, 4%. So you always need to look, how many events are there? I label it at the top so I don't miss any events. So sometimes you have multiple events, like look at this one. What is the probability of spinning a yellow, rolling that 2, and then spinning a blue? So you've got 3 events happening. You have 3 probabilities you need to find, right? So you need to make sure you're finding the probability for each event happening. Then you multiply it across, divide the top from the
Please
bottom.
excuse us an option. As of right now, we are going to try to go outside. It is a light mist, so we're going to try it. We will announce if otherwise. So right now, plan to be going outside. Thank you.
So sometimes you have to do some thinking. What's the probability of rolling an odd number? Well, if our dice is numbered 1 through 6, how many odd numbers would there be? Kylie? 3. The 1, the 3, and the 5. So you need to think, what is my desired outcome? How many are there? If we look at this one, the probability of rolling a 1, 2, 4, or 1, 2, 5, or 6. So you have to add those numbers together of all the desired outcomes, right? Make sure you have that right desired outcome. Do we have any questions on this? Okay, you are going to work quietly, making sure that you are checking that you have all the events listed. So you have all the probabilities you need to multiply together. If you have questions, you want to double check, did I do it right? Did I find all of the event probabilities correctly? Did I round correctly? Come over and check with me. We've got some work time, a little bit of work time. We might have a little bit of homework. Do not rush through. Make sure you're doing it correctly. If you are listening at home, if you have any questions, make sure you come see me. I hope you are well, and I hope to see you soon. Have a wonderful day.